Let's solve this equation for R2. We'll solve this step by step. First, let's subtract 1 over R1 and 1 over R3 from both sides of the equation. This will isolate the R2 term on the right side. Now, let's get a common denominator on the left side. To do this, we'll multiply each fraction by R times R1 times R3 over R times R1 times R3. Now, let's take the reciprocal of both sides. When we flip a fraction, we also flip the equal sign. Let's factor out R from the denominator to simplify our expression. In the denominator, R_1, R_3 has no R term, while RR_3 and RR_1 both have one R term. And there we have it. This is our solution for R2. Let's verify this makes sense. The units work out correctly since both numerator and denominator have units of ohms cubed. To use this formula, you would simply substitute the values of R, R1, and R3 to find R2. This formula is particularly useful when working with resistors in parallel circuits where you know the total resistance and two of the individual resistors, and need to find the third resistor's value.